Good morning. Now, in today's class, we will learn about uh, the next two scientists. One is Albert Einstein, and the other one is J.J. Thomson. Okay, in the last class, we have discussed about Galileo and Isaac Newton. So, today we will learn about Albert Einstein and J.J. Thomson. So, Einstein is a German born physicist and he was named as Person of the Century by the Time magazine in 1999. Actually, Einstein is not famous for his inventions. More than inventions, Einstein is famous for the theories and ideas time in researching on relativity, then space, time, matter, and energy, and so on. In 1905, he has wrote a series of papers and which actually laid the foundation for modern physics. They all dealt with uh, the various concepts of space, time, mass, and energy. And in that work, he also included uh, the theory of photoelectric effect, Brownian motion, theory of special relativity, and the theory of mass energy equivalence. Now we will see some of his important theories. One is a quantum theory of light. In that, Einstein said that light is made up of tiny packets of energy called photons. And he proposed that these photons possessed wave like properties. Then he also found out that when light of suitable wavelength falls on the surface of a metal, electrons are emitted from the surface of metal, and he named that phenomenon as photoelectric effect. And he also put forward a photoelectric equation given as half mv square is equal to h nu minus nu 0. That is, nu is actually the frequency of incident radiation, nu 0 is a threshold frequency, and half mv square is the kinetic energy of the electrons ejected or emitted from the surface of the metal. So Einstein was successful in explaining photoelectric effect. So for that he was awarded Nobel Prize in Physics in 1921. So mainly for his discoveries on theoretical physics, especially for the discovery of the law of photoelectric effect of tiny particles. That is a random, that is not in a regular pattern. That is the meaning of random. Okay, so Brownian motion is nothing but a random zigzag motion of tiny particles that are suspended in still water. Okay, from that he calculated the size of atoms and Avogadro number. And actually that theory has got two parts. The first part consists of the formulation of diffusion equation for Brownian particles, and in that equation he related diffusion coefficient to the mean square displacement of the Brownian particle. Now, second part of the theory consists of a relation between diffusion coefficient to measurable physical quantities. So, using this concept, Einstein was successful in determining the size of atoms and how many atoms there are in one mole. Another very important concept that Einstein put forward was the special theory of relativity. Okay, that is in 1905, Einstein showed that how measurement of time and space are affected by the motion between observer and the and what is being observed. That is between observer and the object. And he proposed a new way of thinking about the mechanics of objects approaching speed of light. And the two most important postulates that constitute the special theory of relativity is that the first one is that all laws of physics takes the same identical form in all inertial frame of reference. Inertial frame of reference means unaccelerated, that is not accelerated frame of reference. Okay, that is almost all laws of physics will be identical in all inertial frame of reference. That is the first postulate. Now the second postulate is that the speed of light is the same in all inertial frame of reference. So this was later named as the theory of special relativity, and then but this has got two consequences, many consequences. One is length contraction, time dilation, mass energy equivalence, relativistic mass, and relativity of simultaneity. Now let us see length contraction. That is a consequence of special theory of relativity. Suppose that a moving object's length L is measured. Okay, consider an object and let L0 be the rest length, that is length of the object when it is at rest, and let L be the length of the moving object. Okay, so according to length contraction, it states that a moving object's length, that is L, is measured to be shorter than its rest length, that is or proper length, or the length of the road when it is at rest. This is called Lorentz contraction or Lorentz Fitzgerald contraction. And if an object of proper length L0 is moving with velocity v, then we can write the relation as L equal to L0 root of 1 minus v square by c square. V is the velocity with which the object moves, c is the velocity of light, L is the L is the length of the moving object, and L0 is the proper length or length of the object when it is at rest. Now this particular term, that is root of 1 minus v square by c square, is less than 1. So definitely L is less than L0. Hence we gave the name length contraction. Next is time dilation. It means that time interval on a clock which is in motion related to an observer will appear to be dilated, that is it will appear to be increased when compared with the time interval on a clock which is at rest. Okay, so that means a moving clock ticks more slowly than a clock which is at rest. It is given by t equal to t0 root of 1 minus v square by c square. Since the denominator is less than 1, t will be greater than t0. Hence we give the name time dilation. Now mass energy equivalence. So we know mass and energy are different manifestations of a same thing. That is, they are not independent. They are their separate conservation principles are properly a single one. That is nothing but the principle of conservation of mass and energy. Mass can be created or destroyed, but when this happens, an equivalent amount of energy will appear or disappear, and vice versa. Okay, so mass and energy are different aspects of the same thing. That is, once a mass is created or once a mass is destroyed, an equivalent amount of energy will either appear or it will disappear accordingly. That is called mass energy equivalence. Okay, that relation is E is equal to mc square, and based on that we can explain nuclear reactions. Okay, now relativistic mass is nothing but mass equivalent to total energy of the system. It's given by velocity v. Now relativity of simultaneity. Consider two frame of reference S and S dash. Suppose that S dash is moving with a velocity v relative to S. And now let two events occur simultaneously in the system, and let the time interval measured by the observer at rest in the system S is 0. That means time interval delta t is 0. Then the time interval between the two events observed by an observer in the frame S dash will not be 0. Instead it will be delta t dash will be equal to 1 by root of 1 minus v square by c square into v by c square delta x, where delta is the spatial separation or the separation between the events in S and S dash, or spatial separation between S and S dash. So we are considering two frames and an event is occurring in the two frames simultaneously. Time interval measured by an observer in S is 0, whereas time interval measured by the observer in S dash is delta t dash is equal to root of 1 by root of 1 minus v square by c square into v by c square delta x. So from this relativity of simultaneity, it states that two events which are simultaneous for an observer at rest will not be simultaneous for an observer in motion. That is, for an observer and at rest, that event will be simultaneous, but for an observer who is in motion, that event will not be simultaneous. That is, simultaneity is relative. Okay, that is what it is said. So relativity of simultaneity states that two events which are simultaneous for an observer at rest will not be simultaneous for an observer in motion. That is, simultaneity is relative. Next is general theory of relativity. So in special theory, it was concerned only with inertial frame of reference, that is, frames that are not accelerated. Later, Einstein put forward general theory of relativity, and it includes the effects of acceleration, that is, space and time are and here he proposed the principle of equivalence of general relativity, and it states that an observer in a closed laboratory cannot differentiate, that is, distinguish between effects produced by gravitational field and those produced by acceleration of the laboratory. That is the principle of equivalence of general relativity. And supporting that theory, there are many experimental evidences, and those evidences are given that you can just go through. So all these laid the foundation for modern physics. So Einstein, more than his inventions, he was famous for the discoveries or famous for the theories that he has put forward, and that actually laid the foundation for modern physics, as I said earlier. Now next we will learn about J.J. Thomson. Now he is a famous scientist who started a new branch of science known as subatomic physics, and he discovered electron, for which he was awarded Nobel Prize in 1906. Then he was uh, very intelligent in almost all his works, and he is one of the most revered figures in the field of physics as well as chemistry, especially his contributions lie in the area of atomic physics. Then he published 13 books and more than 200 papers, and he worked in Cavendish laboratory, and he has completed his graduation under Lord Rayleigh, and he was a member of the prestigious Royal Society. He was then so he has conducted various researches, especially on the conduction of electricity through gases. That is, we know cathode rays are radiations emitted when a voltage is applied between two metal plates inside a glass tube filled with a low pressure gas, that we all know. And he showed that these cathode rays consist of charged particles called electrons, and it is these electrons that conduct electricity. That particular research work was highly recognized, and he was awarded Nobel Prize in Physics for the discovery of electrons, or for the discovery of the conduction of electricity through gases. Next is the discovery of electron. Then this theory was his discovery of electron was widely accepted, and he proved that through his experiments with cathode ray tubes that almost all atoms consist of tiny negatively charged subatomic particles, and he has discovered many particles which were 1800 times lighter than hydrogen. Then he announced the first discovery of subatomic particles, which Thomson called by the name corpuscles. Later, these particles were given the name electrons. Then he proposed the plum pudding model of atom. This you might have studied in your lower classes. And in that, he considered that he proposed a model of atom in which the electrons were distributed in a uniform model, played a vital role in the research of atomic structure. Then this was one of the groundbreaking discoveries of that time. Next is mass spectrometry. J.J. Thomson's efforts in measuring the mass to charge ratio of electrons and ions was very crucial in the area of mass spectrometry. And he has modified an apparatus for photographic method of recording parabolas. He created the world's first mass spectrometer, and he plotted the intensity of ion against relative mass and published the world's first mass spectra. And the Thomson symbol Th was used as a unit to measure mass to charge ratio in honor of J.J. Thomson. Then he has also contributed in the invention of television. We know CRT, that is cathode ray tube, is the basis of many modern day inventions such as television, etc. Then during his cathode ray experiments, he applied a magnetic field across the cathode ray tube, and he discovered that some of the rays bend away from the magnetic field, and this laid the groundwork for the development of cathode ray tubes, uh, which are then used to modulate or accelerate or deflect electron beams onto the screen to create the image. That is how we see images on the screen of television, thus leading to the invention of the first television sets. What are isotopes? They are actually the variants of a chemical element that have different number of neutrons. He believed that stable or non-radioactive elements did not have isotopes. However, Thomson proved otherwise. That is, earlier it was believed that stable or non-radiative elements did not have isotopes, but J.J. Thomson proved it otherwise. That is, he channeled a stream of ionized neon through a magnetic and electric field. That is, he passed a stream of ionized neon through electromagnetic field, and he used various deflection techniques just to measure the charge to mass ratio. So in doing so, what he discovered was that neon was composed of two different kinds of atoms, and thus he was successful in proving the existence of isotopes in a stable element. So the existence of isotopes in a stable element was another invention that Einstein has put forward. Then his work has influenced a lot of young scientists and research scholars, and later they all became a renowned scientist in the field of science and technology, and some of them were Ernest Rutherford, Barclay, Niels Bohr, Max Born, Bragg, then Francis William, then Horn Williams, Charles Thomson Rees, etc. Okay, so when you are writing about the scientist J.J. Thomson, you'll have to mention all those areas where he has made his contributions. One is this one, existence of isotopes in a stable element, in the television, mass spectroscopy, plum pudding model, discovery of electron, then experiments on conduction of electricity through gases, then a brief report on how his education was, then specify all these theories that he has put forward: relativity of simultaneity, relativity mass energy equivalence, time dilation and contraction, special theory of relativity, Brownian motion, then quantum theory of light, then his early life and his honors that he has received. Okay, so for today this is enough. Thank you.